Welcome to Farnsley Makerspace. My students and I are working on creating a hands-on 6-week class. We're at the middle school level, but I think it could be applied at other levels. And students basically are assessed on their efforts and what they can prove that they've learned rather than maybe on the success of their project, which seems to have gotten more buy-in from the students. It's kind of that growth mindset. Okay, our format is basically students get their assignments or their challenges on Mondays, and they can think about them, plan, do a little bit of research. Tuesday, they wrap up their research and they correctly cite their sources to tie in that language arts application, and they have to create a supply list. Wednesday and Thursday are spent building and testing and continuing to rebuild and retest. And then on Friday, we test our item. We kind of have a showcase. You draw or sketch your project, and then we have a reflection on how you feel about it. Okay, for my standards, I use the International Technology and Engineering Education Association standards for technology literacy. And basically, I did 10.G to 10.L. And I have them all listed here if you'd like to look at them. Okay, my learning target stays pretty much the same every day. It's that we can analyze a given set of criteria and to use the engineering design process to work as a team. My students work in teams of 2, sometimes 3, depending on the project, to design and build a device that solves the problem within a given amount of time and with the least amount of materials. That way they have to incorporate a little bit of math as they calculate and keep track of how much they've used. Okay, here's a copy of the rubric that we grade them on, and I have the 4 categories of beginning, developing, accomplished, and exemplary. This one happens to be for the compound machines, which was our second project. And basically I follow the same rubric, just changing or making it apply to the specific activity that we're doing. Here's a listing of the challenges that we've done so far. We started off with building. I thought that would be the most interesting, so we did some research and we built a table or stool from only paper and masking tape. And we put some criteria that it had to hold the most weight possible with a minimum of 4 inches. And then after we did a lot of research and playing around with that and accomplished that and found out that building was kind of interesting, then we studied for our second project simple machines. And then our actual project, after we did a little research, was to combine our simple machines into complex machines, only the challenge of that was that I was only going to let them use paper clips this time. Our third project, we decided that we would like to maybe make our machines go automatically, so that would require a motor. So first we had to learn how to strip wire, and then we worked on building a motor from a battery. And then finally we decided that batteries were fun and we know how to strip wire, so then we decided we would try to build bristle bots, and we used toothbrushes. A couple students brought theirs from home, and we worked on the criteria for that. And then finally what we wanted to do was to build a theater-style projector, and we were going to watch the video of ourselves doing all these things and maybe watch another movie while we ate popcorn on our homemade theater-style projector, which we'd made out of laptops. Another challenge we've had is to see how much we can accomplish without having to buy anything. Like for the paper tables or stools, we got our paper from recycle bins. We did our masking tape in 60-foot strips, and that was like $2.99 a roll. For the paper clip machines, we had paper clips around. We found styrofoam plates from the cafeteria. We did buy some pliers from the Dollar Tree. Since we own the pliers, then we decided to get wires out of recycle bins and strip those. But basically we just kept kind of building. Well, we have these supplies already. What can we get to go with them so that we can build more things? The theater projector project was pretty much going to be our ultimate, where we took the old laptops that we thought we were going to be pulled from service and we built that into a projector. So far, we've been unable to do that project because they have decided that we're going to try to refurbish those laptops and get them back into service. So if anybody's got any old laptops out there, we might have a use for them. Okay, without the students, this project would be absolutely nothing. They've had an incredible amount of buy-in, and they seem very enthusiastic to wanting to come to class, and I have students wanting to rotate to my class. So the next few minutes are going to be my students well, they're very proud of their activities, and they have done a good job, so rightfully so.
Hi, I'm Clayton, and our first project was to design a paper table that would withstand 200 pounds. Here.
The paper table was created by me and Jake. This is the model of it right here. When she first said to create this, I really didn't know what she was talking about. I was kind of nervous to kind of make it, but it turned out pretty good. Jake?
The paper was made out of 62 pieces, and it held 157 pounds.
And, hold on. Well, take your shoes off so he can stand on it.
Get the book.
Put the book.
And they need to put a book on here.
To keep it steady.
Our second project was to design and build a complex machine that incorporates multiple simple machines using only paper clips. Kaylee and Tyler?
Alright, so this is our paperclip machine. What it does is basically there is multiple parts that depend on each other to roll and spin across with each other. What we do is we make coils out of a jig, and we use pliers and our own hands to make these coils, and basically it just makes each other spin.
To prepare for the next project, we had to strip wire without cutting it and determine the components and which ones will conduct electricity the best. Kaylee?
Alright, so basically what we had to do was find copper wire and other big wires that we didn't use. So we took scissors and regular wire and we cut around it and then pulled that off. And then we just ripped the rest, put a little cut in and ripped the rest off. And then others was using, and then there was copper wire in there.
Our next project was to design and build a motor from a D-cell battery and paper clips to potentially operate your paperclip machine. Nathan?
So what I tried to do was put the magnet on here so it can conduct enough electricity from the D-cell battery to go through the copper wires and to make the copper circle spin. However, it didn't work out that much.
Next project was to design and build a moving object from only a battery, pager motor, and toothbrush that can travel 20 inches in a straight line. Caleb?
Hello. What we used to make a bristle bat was a toothbrush, Mars battery, a watch battery, 2 paper clips, and a rubber band and a motor.
Alright, how this works is the pager motor, it vibrates and the vibration transfers down into the bristles, and it makes the bristles move very fastly, and it wiggles.
Okay, that's about all we've got for now. Thank you so much for your time and consideration. Hope you got some ideas maybe could work for you. And I think we're now thinking about maybe leaving our electronic mode and maybe going into construction and building some gingerbread houses. So we'll be planning some more things to do. Thank you again for taking the time to view our video.